with your old school names. Don't matter which town or shores, if you're down for the cause, then it's yours. Kicking off doors, cause we insist, we got the hot style not to miss. So why you bounce to this? Bounce, baby. Bounce, baby. Bounce, baby. Hey, yo, bounce.
Can you hear me now? Yes.
Yes. Big hand for DOS Man for doing this lockpick stuff upstairs. Who's going to come upstairs?
Thank you. And thanks very much for Deviat Olin and all the tool guys and everyone else, Shane, and everyone else that's been helping out up there. Give them a hand. Am I ready to go?
Yeah, we're rolling.
All right. Well, I'm DOS Man with the Packet Sniffers. A little bit about myself. A couple years ago, I came to NOTACON, and they had a pretty cool lockpicking talk. Jimmy and Colonel Panic, what happened? They gave a real cool talk, and I played around with lockpicking a little bit before then, but I hadn't gotten real serious, and I bought my first set from them. And here I am, and I've kind of learned a little bit more since then. So we're going to go ahead and get into some mechanical locks. Going to show you about lockpicking for those that haven't been up to the lockpicking pagoda area. Going to do some more advanced mechanical locks, and I'm going to transition to like the electronic components, like integration of electronics into locking systems, and show you what this does, sort of. So, lockpicking, safe and fun sport for everyone. I'll start off with the legal aspects. A lot of people ask, is it legal? Is there anything questionable about this? Lockpicking itself, as long as you're not breaking the law generally, is clean and safe. Most laws in most states are awarded so that as long as you're not doing anything illegal with your lockpicks and such, you're okay. A couple of states, that's not the case, like Tennessee. I kind of wanted to give this talk at Freaknik, and then Skydog sent me a note and said, you might check our lockpicking laws, they changed this year. And then I found out that they'd made it illegal to even own lockpicks or safe cracking materials or something if you're not mostly employed as a locksmith or licensed or something like that. I can't really speak for any other states, but check your local listings and such. For the most part, it's usually okay, but standard disclaimer. And the argument a lot of people like to make, aren't you training people to be burglars? And lockpicking takes a lot of practice, a lot of patience. Any house or vehicle is vulnerable to a crowbar and takes minimal skills and training to learn how to use that. So that's kind of not necessarily a valid argument to say that just knowing how to pick locks makes you a criminal. Let's see, I'll talk about a couple different types of locks here. I'm pretty much only going to talk about pin tumbler locks. There's other types, warded wafers and lever locks. I'm going to get mostly pin tumblers, electronic locks, and that's about all I'm really going to touch on. Dimple locks, which is still a pin tumbler lock, but I'll show you what that is here in a moment. And just so you know, you get into lockpicking, it's a pretty time-consuming sport, or playtime, whatever. And so I went to Washington, D.C., and I'll have a couple more things with this, about this vacation I took. So I'm in the National Gallery of Art, trying to expand my mind, learn a little bit more about things other than lockpicking. And of course, the first thing I find is, in the background, a set of warded keys. Sort of basically like a skeleton key. I won't go into what makes a warded lock different, but anyway, it's not that difficult to work on those usually. All right, so how does a lock work? A standard pin tumbler lock. You've got your housing, you've got your plug, and you've got your pin stacks. And you notice the pin, if you have like say something that's circular inside of something else and you're trying to turn it, the pins are blocking the plug from turning. And what your key does is line the top pin and the bottom pin up at the shear line. So that's really all it boils down to. The lock picking is essentially operating the lock without the key. And the way it works is because mechanical defects, no matter how precision you make your pins and such, your little holes in the lock, it's going to be slightly different on each pin. So when you're picking, you raise one pin stack up where the top and bottom pin split. One pin will catch, and the plug will turn just a tiny little bit, and it'll catch one of these pins up above the shear line. And then the next one will catch, and then you'll pick that one, and the next one, and such in sequence, and eventually all the pins will be above the shear line, all the top pins, and the plug will go ahead and turn. There's different ways of getting that to happen, and there's also things that they add in to make this a more difficult proposition for you, and actually just makes it more entertaining for you. The tools of the trade, you've got, first tool is your tension wrench. That's what these 3 pieces on the end are. That's what you insert into the keyway of the lock. You insert that right there where the key is, and let me, insert your tension wrench into the top of the keyway, and let me go back up to the locks here. There's really no right or wrong way to use your tools as long as you use them that works for you, but starting off with, you put your tension wrench in the top end of the plug, and unfortunately I don't have a real good picture of the keyway, so I can't, but all I can really show you is, like say, take your standard master lock, you get your tension wrench in, you're holding it so you can apply minimal pressure on the tension wrench. You don't want to put too much pressure. That's usually the biggest obstacle to overcome, is using just the right amount of pressure. Everyone always starts off putting a whole lot of pressure on their tension wrench. And the other tool is the rake. Those dealies on the end, there's different types of rakes, hooks and such. Generally a rake is something that you're going to just kind of like put it in and wiggle it back and forth. This is a hook, so I'm just going to do it pin at a time. And you'll notice the block hasn't opened yet, but it's picked. And that's the other thing when you're starting out that you want to make sure you realize is that the lock's not going to pop open the moment it's picked. But as soon as you should feel the tension wrench give with each pin. And eventually you'll feel it get loose, and then it's open. Thank you. Of course, I picked a very easy lock to make sure I could get it open easy. So Master Lock is a pretty good one to start on. I'll say that they're kind of a medium quality lock because they actually are well machined and well made. You get a very cheap Chinese made lock, and there's so much going on in their shavings, junk, and movement play that it's hard to tell whether you've got a pin set or not. Master Lock, even though it's a quality, but that's also why it makes it easy to pick and learn on, because there's no junk in there, but there's no extra security features. So I'll show you those here in a moment. Also, I stopped by the International Spy Museum while I was in DC, and I'll say I had high expectations, but I was a little let down. It was entertaining, but I don't know. Safe cracking, you don't use a stethoscope for safe cracking. This talk isn't long enough to go into safe cracking or anything. It's all about touch and the dial and feeling your discs and the latch catching on the disc. They've just got a set of, they had this set of lock picks on display. This is like standard issue spy equipment. Okay. Whatever. The only thing that was interesting to me was really the key casting kit, and if you've ever seen it in a movie where they like put a key in like some putty and try it on both sides. Well, this is how you actually make a key from that. It's some type of, low melting point metal that you can melt and then pour into the impression that you've made. So anyway, and also if you have a chance, if you have to choose between the International Spy Museum and the NSA Cryptologic Museum, absolutely go to the NSA Museum. It's 10 times more interesting. All their stuff is real. You get to play with an Enigma machine. kind of not necessarily the same as lock picking and stuff, but it's a lot more fun, I think, to a lot of people that would be here today. Okay, back to picking and different techniques. So basically, like I said, I pick that a pin at a time, but basically if you take your rake and you can just kind of do one of these numbers, and I don't know that I'll get it open with this, but okay. You just basically, you're putting very light pressure on the pins. You're just kind of like bouncing the pins, and you're just basically, you just want to use a very minimal force at first on both the tension wrench and your rake. If you push all the pins all the way down into the lock, you're going to overset them, and an overset is where a pin binds, but it's you push the pin too far down, and it's a false set. You're past the shear line where the two pins meet in the middle. So again, a lot of this I can probably we'll be doing more of it upstairs after the talk. So let's see here, security pins. This is where things get a little bit more interesting. You've got like a mushroom pin, and what happens? It feels like it sets, and it does set, but it's a false set because the pin's trapped in the plug in the way where the pin resides. So, like I say, if it's nice, pick it twice. If it sets, but it feels like it's too high, go ahead and set the pin a second time, and that's where you learn a little bit of tension wrench technique, because you have to back off the tension wrench a little bit and let the plug turn backwards, and not so much that the other pins unset themselves, but it's just kind of a fine technique that you gain with extra practice. There's other things besides mushroom pins. There's I don't have an example of spool pins, but they're basically, it's like this, but it's like a notch on both ends. It's like a spool of thread, basically. There's other exotic designs. American locks, they like to use these serrated pins, and I'll say I can't get these yet, except by chance or random or something. I can't really pick, serrated pin locks or anything. And I'll also say I'm not like any kind of a lock picking master. I'm still learning. It's fun. It's like you grow over time, and I'm still relatively new, I think, in this sport. I toss in a public service announcement. Does anyone have one of these lock and leash locks? They have lead paint, so they're dangerous. I'll also point out that they're really pretty much most of Master's dial combination locks. They're vulnerable to bypass techniques, and a bypass is basically any way that you open the lock without manipulating like the pins or the combination or something. If you look very closely with some good light, and I've not looked at this specific lock, but other ones from Master that use the same technique, and also TSA locks. If you look very closely between the dial, like if you can see like the edge of like where the dial is along the edge of the lock, a lot of times you can see like one little space underneath that dial that's a little bit different, and it's not something I don't think I can explain very well, but you can visually pick that lock with a lot of those. And a lot of dial combination locks are vulnerable to that type of attack. You can sometimes use sound, listen to what it's doing, but mostly my experience has been visual, watching what it's doing. Also, there's nothing magic about lock picks and stuff. You can make your own. And especially once you get to where you can rake open your master locks pretty easy, and you get back to where you're picking security pins, you need to start to learn how to use a hook pick, and it's basically just looks like a finger, and like say that or that, and that way that you can set it twice. Hacksaw blades I use for picks. My favorite hook pick is one I made out of a hacksaw blade. I've got a half diamond I don't use very much because it's pretty big, but I mean you can see it's a hacksaw blade on the end there for the handle, and with some fine sandpaper you can sand that down, make it a good quality smooth tool. Tension wrenches, headphone bands, windshield wipers, and the old standby street cleaner bristles. Everyone talks about using those. All right, bypass attacks. Again, I kind of had touched on that, and visual and audio, kind of the barehanded attack method. Padlock shims, that's kind of a neat thing to show off. I should have been a little bit more prepared. You've got like your standard master dial combination lock that everyone used in high school. And you've got like a shim, and this is basically just something that you shove in, and let's see if I can do it here. You shove it in sideways and you use these little wings to twist it open. So a lot of places you can order these a set, for 20 or 30 bucks, and you want several of these because they tear up pretty easy. It's pretty thin steel. It's just thick enough to get the job done. And you can shim regular padlocks as long as they don't have steel balls in them. I don't have enough good shims. I usually demonstrate on this old Yale. It has a pretty sloppy tolerances now, but my other shims broke. So, and also automotive opening kits. Those are bypass tools. Where you're shoving something down the door. You're opening the lock of the door without manipulating the lock itself. And that's what I usually show off. You put your shims in on both sides with this. This one only has a latch on one side. There's only one indentation on the shackle. Most padlocks have an indentation on both sides of the shackle, and the shackle's been pulled up. So this is another technique, and this will kind of lead into bumping. A snap gun, basically you pull the trigger, and this piece snaps upwards with a very sharp motion. And basically what happens, say if this is the classic example is using the example of how pool balls work. And say you hit your cue ball, it bounces into the first ball, then the energy transfers into the second ball, and the blue ball and the white ball stay input. So that's kind of a standard kinetic energy transfer of how the snap tool works. And why that's important is basically you're separating the pins across the shear line, and in that brief moment you can turn the plug and open the lock. Bumping is interesting because it doesn't take necessarily any real special tools. You can make a bump key out of any type of key as long as it fits the keyway of your lock. You can shave these down. It's basically you take the key down to the deepest cut, and you'll notice there's a little tiny triangle on each position of the key. And you're sort of doing this simultaneously across all 4 pins at the same time. And it's shoving them up. You don't have to have a bump hammer or any special tools for that, but it kind of helps. The flexi handle kind of helps that. There are ways to protect against bumping and lock designs. I'm not going to get into that in this talk, but it is possible to design a lock that's resistant to this type of attack. Back to what makes a good padlock. Of course, most of all locks are designed to resist brute force. Resistance to picking and other bypass attacks is kind of a nice add-on feature as far as the way most places seem to look at it. Resistance to liquid nitrogen, which I'll get into here in a moment. This is a couple of Sargent and Greenleaf locks. They make government munition locks. This is the older 831B. It's got a pretty beefy shackle. Like I said, this is the older gen. I'm pretty much only going to talk about the 833 here. And these are pretty fun. I actually had to fight off Han Fei on an eBay auction for this. I don't know if anyone knows Han Fei, but he's a premier lock collector from Toul in the Netherlands. He has a pretty massive collection of locks. This lock disassembles for rekeying it, changing it. The retail price is $1,300. The government, fortunately, your taxpayers taxpayer dollars only pay about $200 for these. It's a boron alloy shackle. It's a Medco cylinder, which is another high security lock. So the government model has serial numbers. The serial numbers are so that if someone actually removes your lock and they replace it, it's pretty difficult for them to do it in a way that you can't tell. And each individual piece on the 833 is serial numbered. The other thing, and I don't know this for a fact, but supposedly the steel alloy is resistant to liquid nitrogen. Like say if you dip the lock in liquid nitrogen and try to shatter it, I don't know. I actually saw a busted 833 on eBay that didn't work that I was really tempted to try to get just to try this out and see if that's the truth.
It's true.
Excellent.
You also can't oxidize the steel with an oxy-torch cutter.
Really?
Yeah, it won't do an oxidizer thing.
Excellent. Well, glad to know that. The other thing is the ceramic inserts. There's these 3 little squares that you can see there, and they're in several different locations in the lock, not just in this location. They're down in this part of the housing. There's not really on the back side because normally the lock is against a wall like this, so the only way you can get to it is like at angles and from the front. And of course, it's got shackle protection, which I'll go into. Pretty much, if you want a good lock that's resistant to physical attacks, anything that's got any kind of shackle protection, like say a disc lock. These are obviously you can't get to them with bolt cutters, but they're not necessarily the most resistant to picking and such. Back to the NSA Crypto Museum. That's apparently it's like a lever lock. It's not a pin tumbler lock, but that's like from 1995 even. The Russians were using this to lock up nuclear weapons facilities. So it doesn't look all that sophisticated. It's only a one-bitted or one-sided lever. That's pretty basic for a lever lock. They can get quite a bit more complicated. I'm going to jump into. We went from high physical security resistance to physical entrance to more fancy types of mechanical locks as far as picking resistance. And the EVA MCS, EVA is an Austrian lock company. I need to check my time here. And they've got several lines of high security locks. One of the cool things they have is this magnetic lock. There are magnets. There's 4 magnets, and there's like one edge, like that edge will be north and south, and that can be rotated. I can't remember if it's just 4 different positions or if it's 8. I don't remember off the top of my head. There's also magnets on the other side are oriented differently, and it's actually one magnet that they magnetize in place. It's a custom process. They come up for that, whatever. So there's these little rotors inside the lock that the magnets on the key operate. And when you pull the key out, they're scrambled. They let's go in here. There's an inner and outer sidebar, and there's 2 sidebars on this lock. And let me go into a sidebar. Is basically you've got your normal pins in a lock. A sidebar is a type of like secondary locking mechanism usually, although this one only has sidebars. It's a bar along the side of the plug that prevents it from turning. And it's usually something that's difficult to manipulate to get access to. So this is the inner sidebar. You've got these little feelers. One's upside down. And when the key is inserted, these little notches, it lets this slide into that. And that's the difference. That's all. It's like about a millimeter of difference. There's the outer sidebar, and that's all it has to move in order to get out of the way of some notches in the lock to allow it to work. They've got these control balls in there, and what's kind of interesting about that is the fact that if you say you have a key that has the right sidebar cut, the right magnets on it, but it doesn't have the right contours on the top of the key. What this is showing is that it'll allow these little control balls right there it'll either force one of these up or it'll force it to be down. Basically what's going to happen is it's going to lock your key in the lock. Either it won't turn, or if it turns, it'll just lock it permanently in the lock if you've got the right sidebar cut but not the right notches on it. And that's a resistance so that you know that someone's tried to get into it. However, that also assumes that you're playing by the rules and using an actual key. You could, say, mill down the whole top and bottom edge of the key, and you can pull it out. Like here's the EVA MCS key, and you could mill down this top and bottom piece, and then if you were able, per se, to pick the sidebar, you can, you would then, if it locked in the 45-degree angle position, you could just use your pick to push the ball down and go ahead and turn it. I've not tested that, but it looks like that should go ahead and work. I'm kind of interested to do some more work on that. And I've got this cutaway. The pictures are all of my own locks, so if I can show these off after the talk upstairs if anyone's interested. That's the newer generation. This is the old generation that I have. The new one, there's some slight differences up there. All right. The DOM system IX10 is it's a dimple lock. And it's a dimple lock because instead of having pins along the flat edge of the key, they're along the wide edge, obviously. They've got some kind of funky things in them. Like this has got a dual row of pins, and the issue with that is that you've got to have a cut that's kind of angled. And the only other problem with that is the fact that you've got to keep the pin from twisting in its position. So basically they're teardrop shape, and there's like basically one edge, like say on the back side, like just all the way up and down the pin, there's like a point that sticks out, and that prevents the pin from turning. There's several different versions. They've got anti-drill pins, which an anti-drill pin would be like before the pin stack, sort of like in the front of the lock, and so if you're drilling it, it's not going to completely stop drilling, but it's going to make it harder. It's going to like force your bit off to the side. It's going to make it go through more bits. You've got pin tumblers that actually have steel inserts inside of them. They've also, let me go back here. They've got these flat-shaped pins, which is kind of hard to get your pick onto because it really is like flat like this. It's not like a dome. So that's kind of a hard thing to get your pick onto. That's about the only place I know of that you could actually use the circle pick, whatever I can't think of what it's called now. I don't even have one in my set now, but the pick that's got a circle on the end of it. Key control. The other kind of funky thing in this is there's actually a ball bearing right there in the end of the key, and at first it kind of looks like scary for picking. Like, what do you do with this? Like, the issue is not really intended for picking resistance. It's more to make it so that they have a patent on the key, and that way that the only way you can get authorized key copies is through the manufacturer. I won't go too much into that stuff here. The other thing this has is a 2-on-1 feature where when a customer buys this lock, they go ahead and put the key in, and if you lose a key or something, what you can do, you put your second set of keys that came with the lock in, and you do a 360-degree turn, and now it's rekeyed to the second set of keys. There's one pin that's different between the first set and the second set. It's kind of a interesting add-on feature that DOM has. A lot of high security locks have an interactive bit. Multi-Lock has that, several other companies. It's my understanding that DOM was one of the first to introduce this, but it's really only for key control. It's not for anything else. The next generation, instead of a ball bearing, is a wheel at 45-degree angle. That's the biggest thing that's different with that. The DOM System D is a sort of like the DOM IX. It's got a kind of that strange looking keyway. It's basically, instead of a dimple key, you've just got a key that's got two halves that interact with the pins. And you've got all the same security features, steel inserts and whatnot. The next thing where I was kind of heading with this talk was hybrid devices. And that's where you're meshing electronic key systems like RFID and such into a mechanical key or a mechanical lock. That's where a lot of things are heading. Of course, the deal with that is if you have someone that can pick this, kind of cool lock, but if they can't interact with the electronic side, then it stays locked. You have to not only pick the mechanical components, but pick the electronic components too. I think most of the locks that have implemented this are doing something where there's actual contact that makes contact with the key. This particular system is just an RFID component that transmits. And unfortunately, Don doesn't actually have anything that combines like the two in like the one physical lock. That's actually, what they have here is for two separate types of locks. So you have your mechanical key for mechanical lock, then, if you just happen to also have the DOM electronic lock systems, you can operate that lock too with the same key. But there are systems that use electronics in them. This is it kind of looks like a Star Trek phaser or something. The RF, it's purely an RF device. It's got its own power. Also, the other thing is that they've got like a system that from the reading material, I couldn't tell if they actually have like a system that actually interacts with the locks, like your key control system that logs all door access and everything. It's kind of read like they had that interacts with all your locks in your complex, so you have real-time data. Most of them have like something where you have to have someone go around and collect data, but whatever. RF key systems. This is where no mechanical parts, things like MyFair that was broken at the Chaos Communication Congress, if I said that right, in late 2007. These guys did some really cool stuff. I mean, they actually sanded down the IC. They actually looked with a microscope at the chip to figure out what the cipher was. And like, that looks like an AND gate. That looks like an XOR gate. What could we do with these gates were lined up? Oh, okay, yeah, this is how they do their encryption. That was really brilliant. Some students, I can't remember, at Johns Hopkins University worked on the Texas Instruments system, and this is, again, a hybrid system that had a mechanical key and an RFID component. So you put it in your car, both of those had to be in agreement, and then it would start the car, and they broke the encryption in that system. Key lock, that's one that I've been kind of interested in for a while. If you have a remote keyless entry for your car, most systems use key lock, and it's a rolling code system. It's now very horribly badly broken. There was a breaker announced for it at the end of at the middle of last year, and I just found out that it's actually been just by monitoring transactions, you can actually, it looks like, just come up with the key and break the system and have basically a box that would, just listens while someone locks their car and walks away, and then there you have the key, and you can retransmit it. Not retransmit it, but then you have the cipher, and you can send a new code and unlock it. And when I was looking at this, I was kind of I was doing a little bit of research before my presentation. I noticed at the very end, first paragraph in Wikipedia had this sentence that said something about Chrysler possibly uses key lock based on this video, and that video is the Packet Sniffers episode 4 that we made a couple years ago. So I had no idea that anyone had listed this on the key lock Wikipedia page. It looks like I found that a couple days ago, and it had been edited out today when I checked again. So I was like, wow, okay, we did an article, now we're an authoritative source on this. Okay. All right. This is something I did several years ago before I was even into lock picking as far as mechanical locks. Does anyone use an AS400 in here? All right, good deal. So I happen to work for a company that may have made these things, and at that time, and some AS400s, some higher-end systems have what's called a key stick in them, and the key stick basically is what it just lets you lock out the control panel. And the idea is that it prevents you from getting to the system maintenance terminal or dedicated service tools in their parlance. And what's kind of interesting, it's kind of nice. You can prevent someone from rebooting your box, getting access to your data without going through the operating system, controls, access controls for your data. The only problem with that is if someone's actually at your control panel, they can just take your disk drives. So, and when I first saw this for the first time, I was working with an old fossil of a guy that was really, he was quite a character. And I was like, hey, what's this key stick? And he goes, he kind of looks at me, he's kind of knew kind of stuff that I did. He's like, you're not going to be able to do anything with that. Just, it's a complicated electronic device you're not going to be able to figure out. This was the complicated electronic device I would never be able to figure out. So, unfortunately, one side effect of the fact that I worked for this company was the fact that since I worked for them, they considered it intellectual property, and they denied me the right to publish my paper on this thing that I built, what I found out about it. So I can't really go into too many details about as far as how it works, but what is there to figure out?
You still work for them now?
No. And as far as I know, they no longer use this. They quit using this not too long after I sent their legal department my paper asking for permission. You'll notice that this is the bud device here. There's the header and some other crazy stuff on it. Obviously, that may or may not plug into where the key stick goes. So basically this box simulates the key sticks. I can't say, it's not really hard to figure out how, but you turn it on and it simulates. The one feature that, of course, that you need to have in an automatic tool is feedback. How does it know that it's got the right tool and stop? An interesting thing about this system is when you put the wrong key stick in, let's say you're a big customer and you've got lots of different key sticks for several different AS400s, you've got to know if you put the wrong one in, why is it not working? So it displays a code on the panel. The system attention LED is illuminated. As far as I could tell, this situation is not logged anywhere in the operating system. Doing some research, I think there might be a way to determine this through the API, when they started setting up like remote control panel access and stuff, but it's not something that's logged. And just for the record, in case anyone from this company is watching, this is all publicly documented information in their service guide for the system. Oops. So basically, if we go back here, so the feedback, of course, is maybe, say, the system attention LED, and this might be, say, a light sensor that you could tape to the front, and this could be a potentiometer that adjusts the sensitivity. It's not going to cooperate right now, but basically, once it finds the right key stick, it finds out because its attention light goes out. And then, of course, you've also got it decoded so you can make a new key stick from this point. So that was something I had a lot of fun working on in my spare time. Other things, where I was heading with this is the fact that there are other things that use key sticks, not quite the same type of technology, not quite doing the same thing, but just, this type of stuff is, breaking electronic locks is not impossible. And there are other things out there that you can do, you can work on or, give you some ideas. I got this from this photo from the NSA Cryptologic Museum. I saw this on the wall. I was like, wow, this is perfect. As far as I understand, it stores symmetric ciphers on the key, and you put it in this telephone unit and turn it. It then allows you to do an encrypted telephone conversation with that unit. I saw it was a key, and it was kind of neat. Other systems, I'm really interested in this thing called a cyber lock. I haven't seen, or I haven't been able to get my hands on it yet. I really like the fact that they say they blatantly say it's pick-proof. And if anyone has, say, an access to some cheap used or other type of CyberLock equipment, that I would love to get a hold of you after the talk. So it's kind of interesting, a USB cable already on the key is like half the work done for you, right? I think I've really sped through this talk. Oh, maybe not. All right, so I thought pretty much towards the end, thought I would throw up some advertisements. Fraternal Order of Lock Sport, that's for, if you're in southern Indiana area or something else, we've got a lock sport group. We get together and talk about computer stuff while we're picking locks, whatever. Lockenpedia, unfortunately my domain's down right now, but it's just a wiki. I like to post lock photos. All the photos I've got in my talk here, my presentation, I took all those photos, and not all of them are on the wiki yet, but they will be, as well as this presentation for anyone who's interested. The Packet Sniffers was a TV show that some friend and myself made a couple years ago. We may have another episode out here in a while. Not related to lockpicking per se, but technical. Hacker Public Radio. Further reading. Obviously, the next step, some good reading material on lockpicking if you want to go further with this. The document formerly known as the MIT Guide to Lockpicking, the LI Guide to Lockpicking, Locksport International provides that document. And they had to change their name to LI instead of LSI recently, unfortunately. High security mechanical locks. There's this awesome book if you like, crazy mechanical locks. There's a really good book. Unfortunately it's about $80, but it's really good. And there's a whole long history of lockpicking devices and patents. If you just do patent searches for lockpicking devices and locking systems, it's amazing what's out there, and it's amazing how long the stuff has been out there. The classic big long guide is Lock Safes and Security by Mark Tobias Weber. That's pretty, $200 or $300. There's 3 versions. There's the civilian version, the locksmith version, and the 3-letter agency version. Also, if you happen to have that, the government version, I'd love to talk to you about that too afterwards. Other websites, Easy Picking, Lockpicking 101, Barry of Tool, Netherlands. He's awesome to listen to and see what he's got. He's got lots of interesting stuff on his blog. Again, Lockenpedia. Don't forget, on the second floor, we've got Gringo Warrior by Deviant Olem. The Lockpicking Pagoda, it's pretty much all together. It's great. Lockpicks and other equipment for sale up there. And I've got some references for where I pulled some of my material. And that's pretty much the end of my talk. So. Thank you. Thank you very much. If there's time, I don't know if anyone wants questions or something, or if we have time. You?
Yeah, where are some other places you can get mechanical picks?
Other place I can get picks? I think Deviant, you still have some picks available for sale? All right, he's the man. We sold out. He's got some. So upstairs, second floor, Lockpicking Pagoda area. What's up?
Have you done any work on credit card type mag locks?
Not personally, not done any work, but yeah, there's interesting things out there for exploring that type of stuff. I wouldn't know where to send you offhand, but
Google for any of major malfunctions work.
there we go.
Look up RF Idiots and Mag Stripe Madness. There's some of the little talks.
Excellent.
Do you
Yep.
own house keys?
Yes, I own house keys. I've got a standard Kwikset piece of junk on my front door. I live in an apartment. I haven't had too big of a bug up my butt to actually go and bother them. They're like, hey, can you use this high security lock? Or would you have a problem if I put this on my door? I don't know. Like I said, most brute force entries are brute force. The lock isn't what's picked. But then again, all my friends can pick locks, but I trust them because they're my friends.
So are you saying that if people want to learn more about lock picking, they can go to the second floor and there's going to be people there to tell them how to do it if they haven't seen that?
Absolutely. There's going to be a whole bunch of lock picking going on up there right after this. So. All right. Anyone else?
Just one more.
Oh, I'm blinded. I can't. There's a light right behind you.
Sorry, sir. I was wondering if perhaps, are you going to share the schematics on your electronic lock there on Lockopedia?
Schematics, not on Lockopedia. Maybe
Please?
you'll be drunk enough tonight.
Now?
Sorry.
Okay.
No. Buy me alcohol. Who knows what'll happen? Oh. All right. Thank you. Ricochet. All right.